Hello there. Thank you for attending our first virtual Marine Science Day. We're excited to have attendees from all over the world with us today. My name is Jason Pappard. I'm a volunteer at VEMS, and I'll be your host for this session. In this session, we're excited to have Dr. Molly Mitchell, marine scientist at VEMS, with us to discuss sea level rise and coastal flooding. Hi there, Dr. Mitchell.
Hi everybody.
Great, good to have you with us, and we have some questions rolling in that I wanted to share with you. The first one here, do you anticipate the Gulf Stream to increase in speed and move back towards Virginia in the future, or is it anticipated to continue to move off coast?
So that is actually one of the unknowns right now. We do not anticipate it in the near future to speed up and move closer, but we don't have a great grasp of how that ocean circulation is going to change with changing conditions. And so we don't know for sure how that piece is going to play out.
Okay. Have sea levels lowered in response to COVID-19 and the pandemic because people are traveling less and staying home more?
Yeah, so that's a really interesting question. Sea level responds to really long-term changes, not short changes. So we're not going to see a response in the near future to any changes that might be happening with less carbon going into the atmosphere. And if we go back to business as usual in another month or 2 months, we probably won't see any impact at all of this shutdown on sea levels. It would take many years for there to be enough change in the atmosphere for a sea level rise to slow down.
Great answer. From sea level rise, what are the threats to coastal wetlands?
Yeah, so coastal wetlands are right at that interface between the water and the land. And the plants that live in coastal wetlands can handle being underwater a few hours a day. When they're underwater more than that, they start to drown and die. They can't handle that. There's not enough oxygen. So what happens is, if there's space on the upland area, they'll actually migrate landward as the upland area starts to get flooded and inundated. And so if there's space for them to move and the elevations are nice and flat, then they will be fine, they'll move inland. The problem in Virginia is a lot of our low-lying lands have development behind it. And also as flooding increases, people want to protect buildings from flooding. And so that's going to put a literal wall between the wetlands and the area they would move into. And so down the road, we could find that our wetlands are just drowning and getting smaller and smaller.
Wow. This is probably one you'll enjoy because I know we've chatted about it before. Can you discuss some of the challenges of communicating sea level rise to the public?
Sure. So the biggest challenge, I think, in communicating sea level rise is these patterns of variability. And so if you remember in the presentation, we like to show us kind of just this line. Okay, sea level's going up like this. But sea level's not going up like that. That's just the average trend. Sea level's going up, up and down, up and down. And so those are annual cycles. But there are also, the daily tidal cycles go up and down and up and down. So if you ask me what sea level is going to be in 50 years, and I say, oh, it's going to be 1.5 feet higher than it is now, that's in an average year, it'll be 1.5 feet higher, or it could be 2 feet higher, or it could be a little less. And so just trying to have help people wrap their brains around what that means for them and their houses is challenging.
I have no doubt. So how do you expect the earlier melting season this year to affect Virginia and its sea level?
We probably won't see a direct effect in Virginia of the earlier melting season. These ocean processes are complicated, and there are a lot of other factors that affect what sea level is like in a given year. So we see these things affect the trend, but in a given year, there's actually a lot of what's causing changes in sea level has to do with the alignment of the moon and the sun, and other weather pattern, atmospheric weather patterns. And so that's why you see that variability around the line.
Awesome. Is there a way that we can address subsidence?
Some subsidence, yes, and some subsidence, no. So I mentioned there were two kinds, and one is tectonic. And so in our area, that has to do with a glacier that used to be in the New England area back in the last ice age. And it melted, and since then, Virginia's been rebounding downward slightly from that pressure of that glacier. That we can't do anything about. Similar to tectonic uplift in some areas, we don't control that. But water withdrawal, which also causes subsidence and is local, that can be controlled. So the less water we pull out of aquifers, the less subsidence we have in those areas.
Okay, awesome. Is there anything that we as the public and individuals can do to help with sea level rise?
So I think there are a couple of things you can do. I think the biggest thing really is to be aware of it and to be aware of how it's going to affect our communities. And I always tell people, know what your community is thinking and doing about sea level. Some localities are really, really proactive about this. And they welcome citizen engagement. And so, making good decisions can help us be more resilient in the future. So there might be places where we don't want to put the new development over here because it's going to be underwater in 30 years. But we could put the new development over here. And that's okay. We just have to know where those are and bring that into our decision making. And I think advocacy from citizens of localities is a really important step in making that part of the decision framework.
Agreed. Let's see, that goes right into one of, are there places in the Chesapeake Bay area that are particularly in danger from sea level rise?
So anything on the bay side, the bay front, is the most in danger, and that's just because the land is the lowest there. So as sea level comes up, it's coming up, it's covering more of the shore this way each time that it comes up an inch. And then after that, the next thing is our urban areas like the Hampton Roads area, because we just have a lot of people and a lot of roads and a lot of houses. And so that's where the flood impacts make a big difference.
Is there a resource or somewhere where folks could see if sea levels continue rising, what our coastlines would look like in 10 years, 15, 20 years?
Yeah, so there's a number of sources. For Virginia, we have on the ADAPT VA website that I mentioned in the presentation. You can go there and you can actually look at a map and see with different sea level scenarios how the coastline will change. If you want to look more beyond Virginia itself, NOAA has some viewers and Climate Central have some viewers that are national scale.
Any idea percentage-wise how much steric changes versus eustatic changes versus ocean circulation patterns contribute to sea level rise?
So that's a really, really good question, very in-depth. There have been scientists who have tried to break this out and kind of budget how much is contributed by each one. I think the thing to keep in mind is that the steric and the eustatic are changing rates, because as temperatures increase faster, then the expansion of the water is going to increase at one rate. But then the glacier is melting. All right, so they're melting at one rate, and as temperature gets higher, they'll melt faster because that makes sense. But they're also getting smaller, so they're getting broken up. And so just like crushed ice melts faster than big ice cubes, the glaciers are going to melt faster at a faster rate, even if the temperature doesn't increase that much. So we can kind of break out what's happened in the past, but what's happening in the future really requires some global models to try and define that.
Great answer there. I know that was a difficult one.
It's a good question.
How have rising sea levels impacted the fishing industry, and how does VIM share research with those industries?
So, I mean, first of all, the VIMS is very engaged with the fisheries, a number of different fisheries industries, and they're very engaged with the Virginia Marine Resource Commission. And so they share information through that venue, through the commission. Rising sea levels is kind of complicated. It depends on the species we're talking about. So a lot of species are marsh dependent, or they eat marsh dependent species. So if the marshes disappear with sea level rise, then that will affect the fish. And the other species that will be affected is, as sea level rises, we have this place where the fresh and the saltwater meet, and that's moving upstream as the sea level rises. So those fish that live in the freshwater areas, if they're in the main tributary, like they're in the James River or the York River, they can just move upstream. But if they're in a smaller river, so they're in one of these creeks that comes off of the James River, like they're in the Chickahominy River, eventually there's not going to be any fresh water left for them. And so that's going to affect their habitat.
Awesome. Speaking of the way that this affects some of the life in the bay and life in these areas, how does sea level rise affect oysters? Do you have any insight there?
It will depend on whether the oysters can build their reefs up as fast as sea levels coming up. And so sea levels coming up, I said 3.2 millimeters per year globally, but I think the part I didn't emphasize is that that's accelerating. So in Virginia, it's about 5 millimeters a year right now in Virginia. By 2050, it'll be 10 millimeters a year. So if you're a oyster that can, keep your rates up at 5 millimeters per year, you're fine. But now you have to be able to do it 10 millimeters per year to persist in the future. So I'm not exactly sure, I'm not an oyster person, I'm not exactly sure how they're going to do that, but that is the complicating factor.
Awesome, thank you. And how is there a plan for erosion control and maintain natural areas of future coastlines?
Yeah, so the erosion control piece, as sea level comes up, erosion does actually speed up a little bit because the water gets deeper, so the waves have a little more energy coming in along the shoreline. But hardening those shorelines, if it's not done really with a very natural setting, if you harden them otherwise, then what happens is we lose our shallow water areas and our marshes, which are both those nurture areas for fish. So that's one of the reasons people are very interested in living shorelines. One of the things to keep in mind about that is that the goal is for the marsh to migrate landward with time. And so we know people have houses there too. So, that can be a really sustainable shoreline to stop the erosion, but it also means allowing some part of your yard to become marsh.
Awesome. Kind of taking that on a bigger level, are there some ways that larger communities on the coast can help mitigate? For instance, some areas are adding sand to their beaches. Is that a good idea, bad idea? Could you kind of expand on that community-wide?
Yeah, so from a community perspective, beach nourishment can be a short-term effective. And by short-term, I mean like 20 years, not 5 years. Because it just moves the shoreline back away from the buildings and that kind of thing. But keep in mind, you're not actually increasing the elevation of, say, downtown Norfolk when you do that. So sea level is eventually going to come up to a point where that's not enough. And so that's where we have to make decisions about how we want to live and how much flooding we're willing to deal with on a personal level and how much we just want to move away from the shorelines.
Awesome. I think we have time for one more. I'll try to pick an easy one for you.
Yeah.
in the, maybe it's easy, hopefully. In the picture of the flooded building, the VIMS
Mhm.
building that we saw, that was dry inside. Do you have just a few things you could say about the dry flood proofing that was used?
Oh, sure. Yeah, it's a really cool building, and there are pictures of it on the VIMS website. So what they have is actually all the windows are above. So the base is built up, I think so it's at 6 feet is the flat floor. And then the windows are another 8 above that. Okay, so it's like 14 feet to the bottom of the window. And then the door it almost looks like a boat door. So the door seals around the edges so water can't get in. And then inside the building, the electrical sockets are all from the ceiling down instead of from the base up. And so that's, first of all, you shouldn't get water in the building until it's crossed that 14-foot threshold, which is a lot of water. But even if water does get in the building, it shouldn't damage the electrical systems.
Awesome. That was some great insight. And there were so many fantastic questions, but our time's about out today. Dr. Mitchell, thank you so much for being here and helping us learn more about sea level rise and coastal flooding. It's really been a pleasure chatting with you today.
Thank you.